a good time to get started. Welcome, everyone. This is DS3 Película. It's Película. We will get into the depth of what it means, but today we're trying to build a movie recommendation engine. Now, this is operating very similar to how Netflix recommends movies. So that is what our inspiration was. And we'll be going through some concepts, some algorithms, and then we'll be implementing the actual recommendation engine in this workshop. If at any point you have any questions, concerns, please don't hesitate to stop the speaker and ask those questions, because at times I think in the flow of speaking, we usually forget about what you are thinking, right? And the best way you tell us is by speaking out loud. So I think we can get started. Cool. So this is Película Recommendation Engine. What does película mean? It's just movie or film in Spanish. We're looking for a quirky word, and it was one, so we chose it. But recommendation. Recommendation, this is the English definition of recommendation, putting forward something with approval as being suitable for a particular purpose. So in this case, the particular purpose is watching movies, and the suitable thing, who is it suitable for? The client, who we are recommending movies to, right? The last part is an engine. An engine is a construct that uses energy to perform useful work. Useful work here is recommending movies, right? So our software code should take in some energy and some information to produce useful work that is recommend movies. All right, that is your breakdown for Película recommendation engine. What are recommendation algorithms? So out of everyone here, who knows what is an algorithm? Very basic. What is an algorithm?
Series of steps.
Okay, series of steps, perfect. What would a recommendation algorithm be? Yeah, go ahead.
It's looking at the previous data you have,
Uh-huh.
and then it goes through the series of steps, and it gives you something new.
Exactly. Something that recommends a new or suitable content using a series of steps. In this, the steps should be granular, meaning our machine could understand, like it should be able to translate every step into machine code, right? So that is what we're going to be writing. Some examples of recommendation algorithms are content filtering, collaborative filtering, contextual recommenders, matrix factorization, hybrid recommendations, deep learning-based algorithms, and bandit algorithms. So we will be looking today at the first three, and the rest, of course, we will share the slides. If you click on it, it's a link. You'll be able to kind of go through it if you want. All right. So let's begin with, okay. Actually, the content filtering example is right here. Can you see? It says, because you watched A Bug's Life, you love a human centipede. Any idea why this is happening? Go ahead.
It's only using the comparison of bugs in the title.
Exactly. It's using words, and the frequency of words based on, so the algorithm it is based on is called word frequency inversion, in which it takes the words and then compares the common occurrences. But the inversion is because you want to ignore words like the, and so on, right? So it is optimizing that. Let's look at content-based filtering as an overall thing. Content-based filtering is an entity to user mapping. What is an entity? Anything. In this case, movies. Let's see an example. We're developing a user profile. For example, Luffy's food profile. Any One Piece fans here? Okay, 2, 3. Cool. Luffy is a character. This is the one with the red shirt, and he likes eating meat. We are understanding the parameters available for entities. So what are the parameters for food? Taste, texture, etc. We set the value of each parameter for each entity. For example, dinosaur meat, because Luffy loves it. Dinosaur meat is savory, taste, and chewy, texture. All right? And based on the user profile, we recommend similar entities. Just like if Luffy likes dino meat, Luffy might like chicken meat, because it is similar taste and similar texture, right? That is content-based filtering. Another example, just to keep you grounded here, is a user to an entity. For example, the user likes cake, which is sweet and texture, soft, sweet and soft. Perfect. Cool. Collaborative filtering. Again, this is a one-piece example, but I'll give you the context because you don't know it. Collaborative filtering uses entity to user mapping. What does that mean? We're mapping a user to an existing entity. Basically, Goldie Roger, which is a user, likes to see adventure. The user also exists, and the entity also exists. We don't have to specify what parameters of the entity link it to the user, just like we did in content-based filtering. Here, this linking already exists, because we have seen that Goldie Roger likes an adventure. He told us. Map a new user to an existing user based on similar characteristics. Now, this is what we're connecting here. Basically, Goldie Roger is very similar to Luffy because they have the same motivations. They want to become king of pirates, right? So what mapping we're doing here? User to user. What parameters are we doing it on? Whatever is relevant in the context. Here, the entity parameters do not matter. We recommend an entity that the existing user likes to a new user. Because they're similar, Luffy might also like a sea adventure because Goldie Roger likes it, right? This is also to keep you grounded here. Entity to entity, sorry, user to user to entity, right? The entity could be anything. If this person likes precious metals and they have similar tastes, this precious metal will also be liked by this user. Basic logic. Any questions about this? No. Perfect. Last, contextual recommenders. Now we're basing our recommendation based on context. We are doing a mapping of entity to user to context. This is an anime called The Masterful Cat. Amazing anime, very wholesome. But we're understanding the user's actions in a certain context. For example, this is the protagonist. And she likes drinking beer late at night after a work day. So Yukichi, which is the user, likes drinking beer, which is the entity, at night on a work day. That is the context, right? We provide recommendations based on the reoccurrence of this context. So, for example, Yukichi had another tiring work day. At night when she comes home, the masterful cat can serve her another drink of beer, and she'll like it, right? That is the entity to user to context. Again, another example, very, very commonly used. At night, when a user comes back home, usually smart homes, turn on the lights, turn on music, stuff like that automatically. How do they learn that? Because in the past, the user liked that action. And in the future, when the similar context occurs, that action is repeated because the user will like it. Cool. So these three diagrams are going to be here throughout to keep you kind of reminded. I'll just reiterate what this means. Entity to user mapping, user to entity mapping, user to entity to context mapping. Context is the time, okay? It's 9 o'clock. Perfect. So these are three examples of recommendation algorithms. What does Netflix do? Now, Netflix uses Cinematch. Cinematch is their own proprietary recommendation algorithm. We do not have access to it, of course. They're a capitalistic company. They're not going to release the algorithm. But we do have access to what data it collects, because they need to do that. They need to tell the users what the users are going to give for privacy reasons. They have been collecting user behavior data, like your behavior on the Netflix platform, ratings and reviews for movies on your Netflix platform, viewing history of any content that you have watched in the past, time and duration for which you've watched, demographic data, meaning your gender, age, etc., and more. And they use a combination of previous algorithms that we discussed, plus more, to recommend you a more suitable match. Where do these come in? Time and duration. Can someone tell me which of the three algorithms would be time? Context. Perfect. User behavior. Any idea? Content. Exactly. And now, we'll be looking at the collaborative filtering part. We'll be looking at how a Netflix algorithm would do collaborative matching of different users because we know for certain that one user likes something. And the second user, we have to somehow map to the first user, and then whatever the second user likes, first user likes, the second user will like. That is how we are going to do a recommendation. So now I'll call upon Anki, who will explain how we'll be doing this process today. Cool. Yes.
Cool. Is the thing moving, like the audio? All right, perfect. Hi, everyone. My name is Anaki. I am one of the co-VP of academics at DS3. The other one is sitting right there with the blonde hair. Thank you all for coming on a Tuesday during a reading week at 11 a.m. I know it's really hard for me to wake up this morning, but like, you guys are amazing. Like, the turnout is amazing here. So yeah. I'll be talking more in detail about how to build a collaborative filtering recommender. I know Aditya already went through 3 different algorithms that we can use, and this is what Netflix has used in their algorithm. Unfortunately, we are not Netflix, so we're going to be focusing on one algorithm only. It's simpler. So before we get started, can anyone give me a recap on how a collaborative filtering recommender algorithm works? Just give me a simple example. Yeah.
So we want to break down some data by which we can compare users, and then if we find a similar user to an existing user who we already have the data for, like what movies they might watch,
Yep.
we can then just recommend those movies.
Yep. Perfect. Very well said. So in the context of movies, essentially we're trying to find user similarity between the existing database that we have. And the way we do that is to see how they rate movies that are already in the database, right? So we look at different users, we see whether they're similar or not, and then if we find users that are similar, then we can have a recommendation to one user based on the other similar user's taste. So conceptually, it's pretty easy. Now we have to show it kind of mathematically, just to show that this actually works, and we need to code it as well. Let me find a chalk here real quick. Okay, so we're gonna dive into the realm of math. Again, I need some participation. So can someone tell me a really simple way that we can visualize user similarity? Yeah. Ratings, perfect. Ratings on what?
On like the movies and series they watch, so when they're rated, you can find like other people's ratings and you recommend them based on some.
Yep, perfect. So, sorry, 1 second. Yeah, so just to visualize this easier, that was very well said, by the way. Let's simplify the problem into just 2 movies, right? And we're gonna draw our lovely X and Y axis here. But instead of them being just X and Y, each axis represents a movie. So I'm just gonna use Barbie and Oppenheimer as an example because, cultural relevance. So Barbie is on the Y-axis and Oppenheimer is on the X-axis here. Now, if we were to plot user ratings for these 2 movies, how would we do it? Let's say the scale is from 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so each user can rate the movies from 1 to 5, like integers, so no decimal points for this example. If we were to plot a user rating, how would we do it on this graph? Yeah.
A point on the graph.
A point on the graph. And how would we determine that point? perfect. So let's say we have three users, right? We have user 1 rating Barbie 5 and Oppenheimer 4. We have another user rating Barbie 4, Oppenheimer 4, and another user here at 2 and 2. We're going to label these points A, B, and C. All right? So based on this, can we kind of see where a user similarity might pop up? Can someone tell me which two users are more similar than the other? A and B. Why so? They're close to each other in terms of what? The distance. Yep. Perfect. So distance is one way to calculate this is one way to calculate how similar two users are. But there is also another way to calculate it. And can someone tell me what that other way is? So just a hint, instead of thinking them as points, think of them as, actually no, you guys tell me that.
I guess like the angle between them.
Angle, how can we calculate the angle between 2 points? Dot product, dude, you're way ahead of me right now. But yeah, so we can think of the points as vectors instead. So if I were to draw make A, B, and C vectors, like where's the line, where should the line be?
From the origin to each.
Yeah. So from the origin all the way to each point. Yeah, perfect. So we know two users can be similar based on distance if we represent them as points, just to see like how close the points are, right? So you kind of answered, how do we measure how similar two lines are? It would be the angle, right? So we have distance and angle. Now, my next question to you guys, would they measure the same thing? Both distance and angle? Would the number that you get from measuring these two things the same? No. Yes?
So isn't point B 4, 4 and point C 2, 2? Wouldn't they be on the same line?
Yes. Thank you. I'm gonna redo this graph because my drawing skills are really bad. And I'm gonna do a better example actually, just to illustrate the point better. Actually, wait. Sorry, 1 second, y'all. Okay, that's slightly better. Okay, so where did we leave off? Distance and angle don't measure the same thing, right? So now the question is, which one should we use for our movie recommendation system, right? Should we use distance or should we use angle? Does anyone have like an intuition of whether we should use one over the other? Yeah.
So I would go with distance, as angle would be more useful to actually compare to movies. So like the example when we both rated Barbie and Oppenheimer 2 and 4, and the second example, or we get the same ratio.
Yeah.
The people wouldn't like the movie the same.
Yeah. So angle would measure like the relativeness between like preferring one movie over the other, right? While distance is just the absolute preference over over the other. So that's why you said distance is more preferable?
Yeah, for grouping, yeah.
For grouping them. Okay. Does anyone else have another answer who think that angle might be a better choice here? Does anyone else think that distance like agree with him that distance is the choice? Can someone tell me why?
Because I think if B has the same rating for Barbie, but has a 0 rating for Oppenheimer.
Same rating for Barbie, 0 rating for.
I'm saying like if you just scale it down, so it could have a very low rating for both.
Oh,
It would still be on the same line, so it's obviously not the same, right? Because the weights will increase.
yeah.
It's just the ratio between those and stuff.
Yeah. So you guys are making like really good points here, just in the wrong direction. So, but like everything you said, like scaling it down and like the relative preference over one movie over the other, that's actually what we want over just measuring the distance. And that's a very simple reason for this. Think about like how a person would rate a movie, and tell me why we might prefer using the angle measure over the distance measure.
Oh, wait. So if you have user A rating another movie a certain way, right, and you can just divide. In assuming they're similar, basically, you can divide the other movie as well by the same cluster.
Similar in ratio, right?
Yeah.
So that we have like agreed upon, but like just like conceptually, why would we prefer this? Like what context are we missing here? Yeah. Yep. Okay, cool. I got your point, and that's exactly it. Is that some users have a more harsh rating for the movies, and some users are more lenient. Like for me, I'm a very lenient like movie like rating person. I don't know what the word is, but like I would rate movies very high up. Like I rarely rate movies anything below an 8 on a like 10-point scale, right? My friends, everything is below 5. But like if we were to like look at the ratio of choosing one movie over the other, it's actually the same. So that can be illustrated in this graph here for points B and C, right? B rates Oppenheimer super high, and Barbie like at 2 here. And then you can see that C also rates it pretty low. But like ratio-wise, you get B here, Oppenheimer over Barbie is just 2, and then same thing as C. Right? So the ratio of them rating one movie over the other is the same. That means that they're twice as likely to recommend Oppenheimer over Barbie. Does everyone follow? Okay, perfect. So that's basically how we're going to use. That's how we're going to like calculate the user similarity in our code. Yeah, question.
What if someone rates both movies to 0, then we get the graph is like,
So if it's just 1 point here. Oh, as in like getting the ratio, you mean? Or
like the gradient of this line is like the line goes through the 0 and 0 point every time.
yep, no, that's a really good question. This example is limited to 2 movies. Keep in mind that when we write the code, we have a bunch of movies in the database, right? So like even if one movie is 0, the chances of someone rating everything 0 is very low. And that's a big part in data science that Malhar will cover later. But right now, just focus on this example. We know that in terms of user similarity, for our purposes, we're going to use angle. And B and C are more similar than B and A or C and A, right? So yeah, questions?
And also, if everybody, like, if one person rates everything 0, wouldn't the angle of that be undefined? So we just have to remove the data.
Yeah, we wouldn't care about that person. That's
No, that is also true. Like, if you're having a mathematical problem there, we can just make our scale from 1 to 5. You know? That is what even IMDb does.
Yeah.
Yep.
They have ratings from 1 to 5. Even like 0.5 is a possible rating. The lowest you can set so that your mathematical thing makes sense.
Yeah.
Yep. That's a big trick in machine learning as well. Like if you ever divide by 0, like you can just always add 1 to everything. So you scale everything up by 1, so you won't just divide by 0. But that's third year stuff. But yeah, so we get this. So now let's talk a bit about like how do you actually recommend. So if B recommends Interstellar, and A recommends Little Woman by Greta Gerwig, which one would C, sorry, if C recommends Interstellar, which one would be more likely to watch? Interstellar or Little Woman? Yeah, probably Interstellar because, in simpler words,
Like, so Interstellar is made by the same person, made Oppenheimer, and since it's twice as likely to like Oppenheimer,
yep.
it's really nice.
Yep, or they just have similar tastes in movies. Right, yeah. So that's the basic idea. We just try to find users that are similar, and then based on that, we find, like if two users are similar, user 2 has seen a movie that user 1 hasn't, and user 2 really likes that movie, then our algorithm would recommend that movie to user 1, because chances are user 1 would also like that movie, since they have the same taste profiles, right? So that's what we're gonna do after lunch. Malhar would go walk you guys through that code. But for now, we do have a lunch break, right? Yeah, we have a lunch break. So how do you want to release? Oh, yes. So during lunch, while you guys munch on your food, if you have it installed from the link that we've emailed you guys or the link that you found on Discord that we released this morning, if you have a Mac, you can ask Malhar for help if you haven't done the installation process. If you have Windows, you can ask Tian here, right? Yeah. Or, okay, yeah, one of these two guys. And if you have any questions about the stuff that I just covered, you can always like come up to me and ask. But yeah, that's it. Release them section by section, or you wanna? You handle that.
One thing I would like to mention is that it's not, your options aren't limited to picking one over the other, right? You can take a combination of these two things, and we'll learn about things called utility function after in the workshop. Not in this context, not in the context of similarity, but in the context of, okay, I have a list of similar users. I have like some scoring mechanisms, and I've ranked the users by their similarity. And each user has rated a bunch of movies differently. Okay, how do I compile all of the movies that all of these users that are similar to me that I've rated and rank them, right? So what's a good ranking system? Do I just take into account the average movie rating? Do I take into account like a localized average movie rating? Do I take into account popularity, for example? One thing that you could look at is if there's 100 users that are very similar to you, and this particular movie has been watched by 60 people, it's pretty likely that there was some sort of hype around it, at least for people that are similar to you, and that might be a factor that you want to consider, right? So we'll talk about all of that later. For now, I need to ensure that everybody has A, the relevant data set, and B, the relevant packages and Jupyter Notebook installed. So can I just by a raise of hands, how many of you have it installed right now? Okay, quite a bit. So for those that haven't installed it, raise your hand if you don't have the installation.md link, the GitHub link. No, everybody has the GitHub link. So I request you to try opening the GitHub link and following installation.md. So I'll show you how to get there. So it should be on Slack. Sorry, apologies. It should be on Discord. If you were to go...
You could also have a QR code.
Resources. What did you say?
just the QR code instead?
Yeah.
Just the last one?
Go back. Yes. Go back. Yes.
Right. You could use this QR code to get the link, but I'd probably just show it to you guys. This is the DS3 Discord. It's in the resources tab. If you were to open this installation.md file. You have a bunch of steps that you want to follow. So depending on whether you have a Windows or a Mac. If you have a Linux-based system that is not a Mac, I'm assuming you are tech savvy enough to do the installation part. But if there's anyone that needs help with Linux, raise your hand too, right? So of course, step one would be to download Miniconda. So you click on this website and you download the relevant PKG file. Do not download the bash file, because when you download the bash file, it's nothing but a shell script. You have to open the terminal and run the shell script. Keep in mind, for those of you who have it installed, you don't have to listen to me. Please proceed, grab food. There's donuts, there's pop, there's, what else do we have?
Donuts, pop, veg biryani.
Biryani, chicken biryani. That sounds, let me say it into the mic. That sounds bussin'.
You're doing Mac help, right?
Yes.
You guys can start lining up.
Yeah.
Who's not gonna eat it? You could just single find this. So take a cutlery and then.
Hey, do you need help with installation?
I'm currently having the Jupyter,
Mm-hmm.
and then I would like to.
Hey, welcome back. So we briefly talked about user similarity, and then I touched upon during the lunch break a little bit on how we can use user similarity in the end to get movie recommendations. This workshop will focus on it, at least from a simplistic point of view. Like Aditya mentioned, we don't have the computational power or the data that Netflix does. I tried looking up if the source code was leaked. It wasn't. That's pretty unfortunate. But moving on to the data set. You have 3 files. You have movies.csv, you have ratings simplified CSV, and you also have df metrics or metrics.csv. We'll talk about metrics later, but for now let's explore movies.csv. Before we begin, I need to make sure that I give credit where it's due. This data set was made available for non-commercial purposes by the GroupLens research project at the University of Minnesota. I think they've been maintaining this since 2012. Okay, the particular data set we're using is called 25M because it has 25 million ratings, right? It has a bunch of other CSV files, so if you were to actually go on the GroupLens website and download the zip file for this data set, you'll have a lot more data. We have boiled it down to a more simplified view to help us focus on the purpose of collaborative filtering, right? So this is movies.csv. As you can see, it's very simple. You have a movie ID. You have a title, which is the name of the movie. Notice that every title has a year in it. This may or may not be important. We'll talk about that later. And then it has genres which are sort of weirdly separated. Instead of them being comma separated, they're separated by this vertical bar. I don't even know what to call it. So yeah, there's 25 million ratings on 62,000 movies by 162,000 users, right? So you have a bunch of users, and then you have a bunch of movies, and every user has rated, maybe a user has rated multiple, maybe a user has only rated 2, and you get sort of this map. Okay. So this movies.csv just helps us use the ID instead of the title or the / genre every time. So we'll talk about why as well on this. Let's move on to ratings or rating simplified CSV. This is not what you have. We'll see what you have downloaded later, but the raw ratings.csv looks something like this. You have a user ID, you have a movie ID. Keep in mind the movie IDs are consistent, so whatever movie ID 1 was in the movies.csv is the same movie ID here, right? So movie 1 was Toy Story, so this is talking about the same person. So user 1 rated Toy Story a 4.0, right? 4.0 on what scale? The scale that they're using goes from 0.5 to 5 with 0.5 increments. Okay? So you could rate a movie 4.5, for example, 3.5, 3.0, right? And you also have a timestamp. This timestamp is when that particular user rated that movie. Okay? So let's talk about these features. Usually in a data set, every column, if it has a title, if it has some significance, if it has some meaning, we call it a feature, right? So this ratings.csv has 4 features. It has the user ID, it has the movie ID, it has the actual rating that that user has given to that particular movie, and it has the timestamp, which is when that user has rated that movie. Why is the timestamp looking like this? Can someone tell me what that is? Yes. Yeah, that's correct. It's the number of seconds after the 1st of January, midnight, 1970, right? Here's a question for you. If we're trying to identify user similarity, would we care about the timestamp? Would we care about when a particular user rated that movie? Yes.
I guess you could use it to account for height.
Definitely. Yes.
The ratings might be more or less relevant depending on how old or new they are, so their tastes might be changing.
Yeah, that's also correct. Yes.
I think that's timestamp is most usable for like the long-term working application, though for movie recommendation software wouldn't be working for 60 years, which is the case where all the timestamps are potentially to be used.
Right. So all of these are great points, and you're correct. We might be using the timestamp to gauge relevance, what movies are popular again, right? You might just think that it's just always the new movies that are being more frequently rated. But for example, if a sequel is coming out of a movie after 10 years, you will see a rise in the number of ratings for the prequel or the original film, right? So things like that do matter. We might consider newer ratings to be more relevant. That's something we can incorporate. But keep in mind, we're just doing a very simple workshop. So we're going to be dropping this feature, right? We won't worry about it. Before I actually go into more details or start with the code, by a raise of hand, how many of you are upper year students? So second, third, fourth. Okay, not a lot, okay? So with that in mind, the starter file doesn't have a lot of code for you to write. It's more about the ideas and how we're going to implement them. Of course, if you are a little bit more comfortable with writing code in Python, you can choose to modify most of these segments to make them work better, to implement different algorithms. So there's that. Okay, so here's a question for you. Why 2 CSV files? Why do we have a movies.csv and a ratings.csv? Why not just, for movie 1, just put like Toy Story here, and then for whatever movie, just put the title and the genre beside the rating? Yes?
We'll have a lot of repeated entries and just takes up space.
That's correct. So it's space efficiency. If you think about it, if 1,000 users have rated Toy Story, then that column for those 1,000 users for the title and the genre will be identical, right? That's a lot of space that we have to use the CSV to store. In commercial products where they use this data, not only do they have the title and genre, they have timestamps, they have metadata, they have descriptions, they have synopsises, they have reviews. All of that adds up, right? So when we're just working with numerical information, it's a good idea to sort of abstract away the details of the movie and just work with the ID, right? Keep in mind, we would actually need the title and the synopsis if we were to do something like content filtering, right? With word frequency inversion, where you're trying to find similarities in the description of movies rather than the user ratings. But in a collaborative filtering perspective, we don't need to worry about it, right? Okay, so that's basically it. Now I'll be showing you guys what I have given you And we're going to start by just going to this and importing pandas and NumPy. Raise your hand if you've heard of pandas or NumPy before. Can someone care to tell me what pandas does? Yes.
So pandas is just a library which helps organize stuff into basically pandas objects, which are like tables.
Mm-hmm. Yeah, that's correct. Pandas is a data analysis package developed for Python. What it does is, usually you have data stored like tables. That's how we visualized it on the slides. Pandas data frames are very similar to just regular tables in the sense that they have column names, they have row names, and you can like index on the column name and the row name to get a particular value. And they have a bunch of neat functions, right? It sort of abstracts away the heavy work. So when you need to get the sum of every column, for example, if it's numerical, you can just call a sum on the data frame and it will output the sum for every column for you, right? Not only does it abstract away this work, it also makes it a lot faster, definitely a lot faster than what I can implement if I were to write it on my own, because they take advantage of just-in-time compilation and a little bit of other, neat tricks that they can do with the compiler, right? What about NumPy? What does NumPy do? Yes?
It's a numerical library?
Yeah.
Or numerical?
It's a numerical library. It helps with linear algebra. It helps with machine learning for calculating gradients. Usually if you're working with vectors, there's data objects called NumPy arrays, which sort of act as vectors and have functions for them. We'll be using both of these. Pandas more than NumPy. So that's that about the packages that we'll be using. There's a third package that I might have asked you guys to install called Progress Bar. We'll touch upon that later. Now let's briefly talk about what this Jupyter notebook is. Can someone tell me what a notebook is in this context? Has anybody worked with a Jupyter notebook before? Yes.
So Jupyter notebook is like really a Python shell but divided into cells and you can write cell at a time, also you can implement like embedded markdown to write common.
Yeah, that's correct. So imagine if all of this code was in a single Python file. Then I cannot execute a particular chunk of it at a time. Jupyter Notebook, one feature, at least one of the most useful features for me, is that I can chunk the code into segments and run them, right? So, for example, once I run this read CSV, I will have imported the data into the variables that I've stored them in, right? Then, if I'm writing code, again, afterwards, if I make an error, I don't have to restart the entire process of importing the CSV files again and all of that. Those variables are still there. I just need to rerun the piece of code that went wrong, that I had to fix. Does that make sense? Cool. There's a lot of shortcuts here. I'll get you guys started with one. So you can use your cursor to select a chunk, and to run it, you can either go to cell and run cell, or beside it, you can see over here, you have the shortcut. For me, it is Control plus Enter, right? But I think if you're on a Mac, Command plus Enter should also work. Yep, Command plus Enter is how you can run this chunk. So I request everyone to run this chunk and import these two. Notice that we actually had to pip install these in the environment before we began. If we didn't, we'd have to pip install them now. Okay, everybody, does the chunk run for everybody? Yes? Great. So the next step is to import all of the CSV files that were given to you. A quick note, Rating Simplified on the Google Drive was a zip file. I request you to extract it and put it in the same folder, right, if you haven't already. So Pandas has a really neat function called read CSV. So if you have a CSV file, you can just call read CSV, and it'll read it into something called a data frame, right? So the type of DF movies is a data frame. A data frame is, like I mentioned, basically Pandas' version of storing a table, right? So you have all 3 data frames locked and loaded, ready to go. So you can press Command Enter, and you can wait for it to run. Notice that over here it says 4, but when you're running it and when it's in the process of running it, it's just an asterisk. It might take longer for some people to get this chunk running, especially considering ratings is a pretty big file, right? Okay. The next step is to actually look into these data frames. So what do these CSVs look like? So movies, as expected, have the movie ID and the title, but it doesn't have a genre. Can you tell me? Can someone tell me why we don't worry about the genre right now? In the context of user similarity. Yes. Yep. We're focused on ratings. If you were to do genre-based rating, it's tough, mainly because data science works well with numerical features, and when you have qualitative features like genre, it becomes hard to correctly interpret them as numbers, right? Sure, you can give each genre a number or an ID from 0 to whatever, but what does comedy being 3 and horror being 7 actually mean, right? Yes?
How about make a list of possible genres and create attributes like is horror, is
Yep.
comedy and stuff like that?
Yep. That's actually one of the best ways to handle this, is that you would have a binary for every single, I guess it's called type in the domain. But as you can see, that would sort of just blow up the data set. Luckily for us, we don't have to worry about it. Okay, cool. So as you can see, the data set claimed that there were about 62,000 movies. There's a little bit more. Great. One thing to note is that these movies were from 1995 and maintained up until 2019. But you see these older movies, I guess these were just added later on. Okay, next we're going to skip this metrics chunk for now, and we're going to go to ratings. Okay, so run this chunk, and you should see something like this. Again, you can see that I've already dropped the timestamp feature for you guys, right? So you have the user ID, the movie ID, and ratings, and you have a little over 25 million ratings. Okay? Right. So here comes the first problem. If I'm a new user, right? Let's say I'm a new user for Netflix, for example. Netflix doesn't know what my preferences are. Netflix has no idea what I like or dislike. So what's one way we can sort of gauge their preference? Yes? Sure, that's one way of doing it. You can recommend them random movies, and then when they watch it, you can take the rating, and then you can create this sort of feedback loop. That is definitely what they do. Yes?
Like show all the movies which are popular, like most popular, or most watched by that week.
So you can, another thing is just to take the most popular movies, maybe the ones that have the highest number of ratings in the past week, or you can take a look at most popular ratings overall by average rating or most number of votes, right? There's a bunch of features you can use. Yes?
Somebody calculate which films let the user to watch and to review based on how many information we get from the movie.
Yeah, that's correct. So it all boils down to, hey, what movies should I recommend this new user and get him to rate so that I have a good understanding or of what his preferences look like or what their preferences are, right? So the question becomes, what kind of movies do I ask this user to rate so that I can build a profile and then do user similarity on this new user, right? The simplest way, in my opinion, is to say, hey, new user, we don't know anything about you. Here's a list of movies. Rate them. If you haven't watched it, just skip it. And once you've rated a certain number of movies, you should be able to create a profile for them, right? So to be able to do that, there's the piece of code that asks the user to rate it, but there's also figuring out which movies to ask them to rate, right? And you guys have brought up great points. Get the most voted, most rated movie, get the highest average rating movie. Another feature that I don't think you guys have mentioned is to get the most variable or variant movie. So what I mean by that is get the movie that has the most variation in its rating, right? Because, and the intuition behind this is the fact that if there's a movie that everybody loves, everybody just has rated it 10 out of 10, then when this new user also rates it 10 out of 10, it doesn't help us, put that user into any particular group. So when you ask a user for their opinions on movies that have a variable rating, you actually you're extracting more information in a sense, because it helps you put the user into one of the two groups, So with all of that in mind, I did the work in advance, and I computed all of those metrics, and I've compiled them into the metrics CSV for you guys. So let's take a look at how that is. So you have movie ID, you have the count, which is the number of ratings, you have the mean, and you have the deviation. One important thing that I forgot to mention was in these ratings, you can look at the ratings.csv, and they were from 0.5 to 5 with a 0.5 increments. But in this CSV that I've given you guys, the ratings are integers. Can anyone tell me why someone would do that? Yes?
It's easier to compute with integers rather than floating point numbers.
Yes, that's definitely a part of it. And then, so that's speed. Can someone give me another reason why I would do it? Yes?
Most things when you ask them to rate a movie, they don't give you like 3.5. They say like they give you an integer usually.
Sure. There's something you guys are missing here. Go back to, it's a very similar reason as to why I don't have the movie title and genre for every rating. Yes. Sure, go ahead.
It's one less number to store.
Exactly, space. A floating point has 64 bits of precision, whereas this integer I can store in 32 bits. In fact, if I want to make this even more efficient, I can define a custom class for a 4-bit integer, because we know that the ratings are always between 1 and 10, right? That way I can save even more space. So these are things that you have to take into consideration when you're doing data engineering more than data analysis, in a sense, how to store it more efficiently. So to actually go from a 0.5 to 5 scale with 0.5 increments to these integers, I just doubled it and converted it to an integer, right? I didn't lose any information, but I saved some space. Okay, great. Going back to these metrics, the count is the number of ratings for each movie. The mean is the average rating, and the deviation is just the standard deviation. You guys might not know the formula, but it just quantifies how varied the ratings are. Okay? I suggest you guys to take a minute and look at this and try to find patterns. Try to see what's happening here. Can someone tell me a pattern relating to the order in which these appear? Yes. It's
by count?
Yep, it's by count, sorted descending, right? I've done this because we'll be focusing on counts, even though I mentioned deviation will probably give us the most information. If I were to sort by deviation, you're probably going to get indie films that have 10 ratings where 5 people hated it and 5 people loved it. Okay, that's probably going to have the highest variation, but then how likely is the user to have seen that indie movie that only 10 people has rated, right? So that's another thing you have to take into account. So for now, we're just going to ask them, the most popular movies of all time, just by count, not even worrying about the rating right now. So basically, our job is to now go through this and ask the user to rate a few movies. What would be a good number of movies to ask the user to rate? 1, 10, 100? Any guesses? Just, I don't want a specific number, but just in order of magnitude. So 1, 10, 100, thousands, 10,000s. How many movies would you rate if you were to try and sign up for a new streaming service? 5 or 10, right? 100 is way too much, let alone 1,000 or 10,000. And 1 is way too little, right? So that's what we're going to do. We're going to rate 10 movies. So what's one way of doing this? Do I just take the top 10 and ask the user to rate it? Would that work? Why would it not work? Mm-hmm. Yeah. That's a fair point. These popular movies do have very similar ratings, so we do fall into the trap of asking movies that have high variance to get more information out of the user, but also taking into account the probability of what movies a user has watched. But what if I were to, this is just in the sense that we've made the decision, we're just going to stick with count. We're just going to ask them 10 movies. It's fine if we don't get a lot of information about this user. But let's say I just take 10, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I just write a for loop over those 10 and tell the user, hey, rate these 10. Will the user always be able to rate those 10 movies? Why not? Yeah, you might not have watched all 10, right? So we can't stop by just taking the first 10. So what we're going to do is we're going to iterate over all of, whoops. There we go. We're going to iterate over all 588. Whoa, what happened? How did we go from 62,000 up here to 588? Yes? That is correct, right? If we're focusing on the purpose of just getting the most popular movies, there's no point in getting movies that are pretty rare to have been watched, right? Notice that by doing so, you do lose information. So you might get a user that only likes to watch Spanish films from the 1970s. And that's a very small user base. And you're probably going to skip out on all of those movies that this user could have, elaborated for hours, and he could have gone about the directing and everything. In data science and in life, there's always exceptions. And there's always users for which a particular algorithm won't work, okay? It's just something that we have to deal with. What we're trying to maximize is the percentage of users that we can satisfy, right? So as long as this works for 80, 90, 95% of users, it is a good algorithm, right? Sure, you're gonna get angry emails, where are the Spanish movies? It's fine, okay? You can curate something for them, especially. Okay, so that's how we dropped to 588. It's pretty likely that you won't have to go through all 588 movies. It's pretty likely you guys have watched 10 of the first 20 or 30, but I'm just going to keep it here, just in case, you know? Okay, so let's go down to generating the profile. So, like I mentioned, we need to query the client on these movies to generate their profile. So we're going to prompt the client until they provide 10 valid ratings. And the first step, well, I don't have a UI, I just have print statements. So we're just going to run this. And this is what the client will see. Hello, before we start, we need you to rate a few movies. Rate it on a scale of 1 to 10. If you want to skip, press enter, right? How is this working? How am I ensuring this? Well, I've made a helper function for you guys that, given a movie title, it will prompt the user for a response. And if the user skips, that's fine. It will just return the empty string. But if the user doesn't skip and gives you garbage input, it will warn the user and ask them to re-rate this movie, right? It also checks whether or not the rating is between 1 and 10. Can someone tell me something interesting about this piece of code right now in terms of data types? Yes?
So we asked for integer, but we get a float.
Yes. Why am I asking them an integer, but I'm okay with them giving me a float? Yes?
It's possible that they might be just entering like 1.0 or something, so we don't want to count that.
That's a really, really good reason. Actually, I didn't even think of that. Yeah, so let's stick with that. That was the reason. The reason I had in mind was we're just calculating distance or angle. In either case, we know how to compute things with vectors. It's okay if we let them rate a film on a floating point scale because we can still do the math, right? Sure, it becomes computationally inefficient, but if a user is feeling like this movie is a 4.35 and not a 4.36, then it's a 4.35, right? User is king. But of course, most places don't allow you to do it. Even IMDb, I think, only allows you to do up until 1 decimal place, right? That again goes back to data storing principles, space efficiency, etc. Okay, so you don't have to worry about writing this function. All you have to do is pass in a movie title, and it will keep asking the user until either they skip it or give a valid rating. Okay? The next chunk is where the magic happens. So we need to now write code that iterates over those 588 movies in that order until we have, as we mentioned, 10 ratings. I'm going to store it as a variable so you can change it. But for now, I'm just going to work with the raw number, 10 movies. Okay? A very good way to iterate over a data frame is you call the data frame and you use the function iter_rows. If you want to learn more, you can click on this link. It will lead you to the documentation. Okay? Right now, not only do we need to prompt the user for their rating, but then we need to store it somewhere. So for now, we're just going to store it in a list. What 2 things do I need to store the ratings of a particular user on a particular movie? Yes. Yep, movie ID and the actual rating. So what we're going to do is we're going to store them in a tuple or a pair, and we're just going to have a list of 10 pairs, right? At the end, you can see that I actually convert this list. df client is initiated as a list, but I can convert it into a data frame using the .data frame function. And then I can just give the column names for each first and second pair. Don't worry about setting the index. We'll talk about that later. But for now, what you want to do is take a look at the iter_rows documentation. You have a for loop, and I want you guys to try and fill this in. I'll give you guys about 5 to 10 minutes to try and fill this function, right? So step 1 would be to call the function. And now we need to somehow pass the movie title. Here's where iterRows comes into play. When you do a for loop over a data frame using iterRows, it returns a series of two things. It returns an index and the actual row. Okay? So what this would look like for our specific example of DF metrics would be the following. The index, in the first iteration of the for loop, the index would be 0, and the row would be everything. It would be movie ID, count, mean, deviation, and title. Okay? And to access a particular value in the row, all you have to do is call row like this, and then whatever column name you have. Right? So if you want the movie, it would be movie. In our case, instead of calling it a row, I've called it a movie because each row actually is details about a particular movie. So this would be movie and then column name, title, for example. Right? So let's see. Right, over here. So it would be movie, and then you want to pass in the row, and that will give you the actual title of that particular movie. Okay? Now, what can the client response be? What are the two different types of client response that you can get? Yes? Yes, one of them is you get nothing because the client skipped the rating. And the other one is the correct rating, right? So now you have to handle it on a case-to-case basis. So if the user skipped the movie, we don't want to add it to our list because we don't know what the rating is. Sure, we have the movie ID, we don't have the second element of the pair. So if it's empty, we just don't do anything. But when it's not empty, right, when the client response is not an empty string, we want to add it to our list, right? So we do that with, how do we handle cases usually? At least when you have two options. If statements, that's correct. So you do if client response, that's the variable I called it. You can name it whatever you like, right, over here. If client response is not equal to the empty string, so if it is a valid rating between 1 and 10, then you want to actually add it to our list. How do we add elements to lists? Any AO8 enjoyers here? Append, that's correct, right? So our list, we've initialized it as DF clients, and I'll talk about naming conventions as well. But you'll do df client.append, and now we need to store a pair. We can store the pair as a tuple, or we can do it as a list itself. So each pair is a list, and then you have a list of lists. So we could do that. The two things we wanted was the movie ID and the actual rating, which is our client response. The movie ID you can access just like you access the title using the movie ID column name. And then after this, you want the client response. Right? Okay. So while you guys are working on that, why do I prefix every variable name with df? Well, at least many of them. Yes. Yeah, and that type in this sense is data frame, right? It's a good naming convention that when you have data frames, you prefix the variable name by df. It's easier to read, it's easier to understand. in general, you want good naming convention because it helps you recall what that variable actually was in case you ever forget, right? Okay, and this last step, very important. We don't want to keep going for all 588 movies. We need to stop once we have 10. So how do we do that? Yes. Yeah, yeah. That's correct. So to figure out, how will we figure out that we have 10? Yes.
You can use a counter or look at the length of the list.
Sure, you can use a counter, increment it every time during the for loop, and then check whenever it's 10, you can just break out of the for loop. Anything simpler? Yes. Yep, perfect. You can just use len on the list of DF clients, and when it's equal to 10, you can break. Right, so let's do that. If the length of DF clients is equal to 10, I say 10, but I'm going to use the variable that I've defined above to make it dynamic, right? If this is the case, we need to exit the for loop. How do we exit a for loop? Break, right? We break out of the for loop. We break out of the matrix 1999. Okay, cool. Once you have this, these last two lines do nothing but set convert the list into a data frame. And when you would do this, you would get two columns. You would get the movie ID. I'm going to abbreviate it as MID. And then you'd get the client rating, which is CR. And you'd get a list of 10 of those, right? So 1, 2, all the way to 10. What I'm doing with this set index is I'm sort of converting it into a dictionary style of things where you can query the data frame on the movie and you will get the rating in return, right? So instead of the index being 1 to 10, instead of indexing like this, well, actually it would be 0 to 9. Instead of indexing like this, I will be indexing on the movie IDs. So you could have like 408 and 318. And if I convert the index to the movie ID, now when I do DF client at 408, it will just give me directly the rating. Okay? So let's do that. Let's run this chunk. Oh, wow. It's asking us for input now. So I'm going to fill in my preferences. I request you all to fill in your own, A, and B, not judge me. Okay? I'm not a crazy movie guy. I might have not seen many of these popular movies. Forrest Gump was all right. Not seen. That's a 9 for sure. Silence of the Lamb. I haven't seen this. Matrix is an 8. I hate Star Wars. Sorry. Jurassic Park was 7. It's a fun, flick. Not seen this. Not seen this. Fight Club is a 10. Terminator 2 Judgment Day is okay-ish. Oh yeah, it's not gonna let me do that. Terminator 2 is maybe a 15. I love that movie. Nope, it doesn't let me do that. Great, so at least my helper function's working. Terminator 2, probably an 8 for me. Again, Star Wars, I hate. Toy Story is 10. Lord of the Rings is a 10. Great. What? That's it? Did I rate 10 movies? Can someone help me count that? Yes, you had a question.
Mine's not working.
Oh.
So, yeah.
It doesn't seem to, so I run everything up and then, okay.
Okay, you might need to restart your kernel. So click restart and clear output.
Yep.
And then click on the cell that you are, and click go to the cell, like click. Yep, and then select run all above. and then wait for it to run the chunk. What is the error? Okay, so you probably skipped on running df metrics before. That was the issue. So it didn't actually import df metrics, maybe. We'll see. Scroll down. So this is this run yet? Yes, okay. And then run this now again.
There we go. Thanks.
Yeah. If you're facing any issues, it's usually, so with great power comes great responsibility. So when you have chunks, if you miss a chunk or you read it in the wrong order, it sort of messes up your flow. And you might have to restart the kernel and run all the cells above it. Luckily, you can just go to the cell that you want, that you're currently at, and just click run all above instead of manually running each chunk. So keep that in mind. Did someone count this? Is it 10? Yes. Okay, great. So that's working as well. Great. And now I have a user or a client profile. The next step would be to compute the similarity. Yes. Is this okay? Okay, cool. So I'm going to use the board now. I know one of you guys were a little bit ahead of Anaki in this matter. But we made the decision, the conscious decision, to use angle, right? Now, angle in a 2D sense sort of makes sense. This is your angle. This is assuming that each movie is its own dimension. With these 10 movies, we'll have 10 dimensions, right? What does an angle look like in 10 dimensions? What does an angle look like in 3 dimensions? It's pretty hard, right? How do we even compute it? Yes?
I mean, like, computationally, we take a dot product, but visually, we take the plane going through the two vectors, and then you find the 2D angle.
That's correct. So you would take a slice, and then you would project, and you would get the angle. Of course, we're not going to be working on that. It's hard to get this raw data just by the data. See what I did there? No. Okay. What we can do is we can compute some trigonometric function of this data. What can we compute? It might be hard for me to compute, given 2 vectors, the data directly, but can I compute sine theta, cos theta, something? What can I compute? What's the easiest to compute? Cosine of theta. Can you elaborate on what this formula is? If you have vectors A and B.
So the dot product of A and B divided by the product of their magnitudes.
Okay. Okay. Is everyone familiar with this notation, either in high school or not? A dot product, so if I were to give a simple example, if your vector was 2D, so that it only had 2 values, a dot product is taking the ith values in each of them, multiplying them, and then adding those products all together, right? So 1, 3, 5, 2. The dot product would be 1 times 5 plus 3 times 2. This is 11. The magnitude is basically, at least in 2D, you can view it as the Pythagoras theorem, right? It's the distance from the origin. So 1, 3, 1, 3, somewhere here, would be square root of 1 square plus 3 square. The good thing is, when you scale in higher dimensions, you can still use this Pythagoras theorem. You just have to do more squared sums for every dimension, right? So if you have 3 dimensions, a squared plus b squared plus c squared, and then take the square root. If you have 4, you also add d squared before you take the square root, right? And so on and so forth. We'll talk more about what dot product we should take and why we can't just blindly use this formula. Okay? But that's our next step. Our next step is to compute the similarity. Okay, is everyone okay with this? Has everyone got their chunks running and put their 10 movies in? Yeah? Okay. So the success of this workshop will be defined by whether or not you get good movie recommendations, all right? So we're going to start computing the similarity. To compute the similarity, I need some data structure to store the similarity value between you and every user in the database, right? And because we're working in pandas, I'm just going to use a data frame that's just going to be every user in the database, and then the value here would just be the similarity between you two, right? So you have user 1 and 15. Then in the database, you can have a column called similarity, and it'll store this value. Okay, what values can similarity store if I'm just using coast data? What would the range of this be? Yes. That's correct. There's a reason why it's not negative 1 to 1, and it's the fact that you can only rate a movie positive, right? So you're only rating in a positive quadrant, at least in the 2D sense. Even in the multidimensional sense, you're only rating in the positive side. So the largest distance to user profiles can be apart is 90 degrees. That corresponds to 0. Cos 90 is 0, and best case, there's a user that's just like you, has given the exact same ratings, then you would get, the two vectors would be the same, and your angle would be 0, and your cos would be 1. So we want the value we get, the higher it is, the closer to 1 it is, the more similar that particular user is to you, right? Okay, so I've written some code for you guys. I'll briefly explain what each line does. Client movies just gets those 10 movies, and just, in particular, just their movie IDs. We don't want their ratings for now. When we need the ratings, we'll go back to them. Then, I simplify the ratings because I don't need all 25 million ratings. I don't need any rating that's not about one of those 10 movies, right? If I'm computing the similarity between two users, and this one particular user has only rated these 10 movies, I cannot compare two users when one of them hasn't rated a movie, right? So I need both of them to have rated a movie. We know the client has rated, whatever 10 movies that you gave them. So we're going to remove everything that's not a rating of that movie. Additionally, we're also going to remove ratings of users that have less than 5 ratings in common. So out of those 10 movies, if some user in the database has only rated 2 of those movies, we will not count that user in calculating our similarity. Can someone guess why? Yes?
Because they're lacking in a lot of dimensions, they're probably going to be similar to, or not similar to everyone.
Sure, that's one way of looking at it. If the user hasn't actually seen those 10 movies, but what if they've seen it and they just haven't rated it, right? Yeah, exactly. We don't know what the user has or has not seen. We only know what the user has rated. If I were to allow all the users to do this, and let's say I rated Toy Story a 10, and so did this particular user, and that user has not rated any of the other 9 movies that I've rated, then I can only compare them in one dimension. And in that one dimension, we both have the exact same rating, which would mean our similarity score would be 1. And how accurate is that? It's not a lot, right? To improve the accuracy, we sort of have a threshold, right? I set it 5 arbitrarily. I've actually, in reality, set it to 50% of the number of required ratings. Again, going back to keeping it modular, so you can change it. Okay, great. And finally, I merge the user rating and the client rating for all of those 10 movies. And then I create a a data frame called df simple. Okay? So make sure you run this chunk before you move on. So cosine similarity, like I mentioned, was this dot product, and then you divide it by the magnitude. What we're going to actually look at is a partial dot product and partial magnitudes. And we'll talk about this. Here's an example. This is the client. The client has rated 10 movies exactly. Okay? This is a random user. He's a movie aficionado. He has rated 100 movies. If I were to just compute his raw magnitude, this number would be too big, and it would also be irrelevant, right? So a partial dot product or partial magnitude is basically for every client and user pair, I'm only taking the movies in common and only using that to compute the dot product and the magnitudes, okay? So that's what we do over here. Now, obviously, dot product is done iteratively, and so is the magnitude. I can just write a for loop, right, to do this. So let's run that for loop. Okay, that ran pretty fast because we didn't actually calculate anything. We need to write code to do that. Unfortunately, due to a lack of time, I won't be able to give you guys this code, but I will. Let's see if I can just grab this from here. Oh. Okay. Right, so it's very similar to the indexing that we've done. I've created 3 columns: user magnitude, client magnitude, and dot product. And I update it iteratively. For the user magnitude, I take the square. Client magnitude, I take the square. And I add it to this. And dot product, I take the product of the two. And to actually get the magnitudes at the end, I just take the square root by using this .pow, .power function. Okay? Now let's run this. Whoops. fsim. Oh, forgot a D there. Apologies. Now this should run. Whoa, 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 whoa. Okay. So this is taking a bunch of time. So while this happens, I'm going to drink some water. And if you guys have any questions, please feel free to ask me.
Can you spell out some basic code?
Mm-hmm. Yes. Absolutely, absolutely. So we've seen what iterows does, right? It loops through the data frame row by row. And in our case, each row is just the rating. It has the user ID, it has the movie ID, it has the user rating, and then I've also already merged in the client rating for that particular movie. And I have like these 4 features for every row. So what I'm doing is when I come across a particular user, right, I know I have to update the dot product and magnitude of that user, right? So what I do is I find that user in the data structure that I've mentioned, right? The data structure that stores all the users and then the similarities. And within that, I have a user magnitude column, and I update that. Right? So the first one is just making sure that the magnitude for the user B, is updated, right? User B's magnitude would be like a squared plus b squared plus c squared dot dot dot. So I'm doing the sort of, okay, let's not use a and b. I1 square, I2 square, I3 square, right? So this is what that step is doing. It's doing I1 square. And then the next iteration, if it's the same user, it's going to do I2 square, and so on and so forth, right? Similarly, the second line is taking the magnitude for the client magnitude, and updating it, right? And the last one is just a mix, because the dot product takes the product of both, right? And we're iterating, and we're updating. Okay? Don't worry, you don't have to write this code. In fact, forget this code exists, in a sense. But yeah, I'm not sure I measured the time, but it probably took 2 minutes-ish, 2-ish minutes to get this for loop, done with. This is what you have as a result. For every user, you have the magnitude, the client magnitude, and you have the dot product. So you have this, and then you have this. So to compute the similarity, all I have to do is divide the dot product by the two magnitudes, right? Okay. One thing that's the purpose of me showing you the time it took for this is because iter_rows is a very expensive function call, right? It takes a lot of time and resource for it to iterate over things row-wise. Usually, there are better ways to do it using functions that are faster. And that's what this next chunk is. So notice how we only had 25 million ratings and 60,000 users. On a larger scale with tens of millions of users and billions of ratings, this would take how long? And this is just to compute the similarity of one user. You'd have to multiply it again by the number of users to compute their similarity, right? So this is an example of a piece of code that does not scale well, right? Instead, I have a different way of doing this, and you can read more about it. It's called the group by function and the apply function. So the ratings that we had, the users were sort of jumbled, right? They were all around. The group by function allows me to look at a chunk of a particular user and all of their movies that they've rated. And that allows me to work on each individual chunk of a particular user independently, which allows me to speed the process up a lot, right? Unfortunately, again, we're sort of over time, so I can't go over or let you do the code, but I'll copy paste it here and I'll run this chunk. I want you to take a look at what is happening here, but also keep in track how long it takes. Okay, so as you can see by the comments, I first reset the data frame because we already had the calculations above. What I'm doing next, oh wait, this is already computed. Sorry, I thought I would have enough time to go over things. But you're using group by on the user ID, and then you're applying a function. You can do group by followed by method chaining. Method chaining is basically run a piece of code, call a function on it, you get a result, call a function on the result, you get another result, and keep going. Yes?
Does it apply just like map compute dot product over the...
Yep, it applies a compute dot product on every individual user ID.
Oh.
Yeah? As you can, for the magnitude, it's very simple. I take the rating for a particular user, I square it, then I group by the user, right? So now I have for a chunk of user and I have the squares of their ratings. I add the squares and then I take the square root. That's exactly what the magnitude is. There's a reason why I have to do group by after and not before, because when you do group by, it will give you a smaller data frame that only has those user ID values, right? And using that group by function, you can only apply functions to this data frame that result in a single value, in a numerical single value. So if I were to group by user ID and then take the square of those ratings, it will give me an error, right? Because squaring the list of ratings for user 10, for example, isn't a single value. You'll get however many values there are for the movies that that user has rated. Okay, but this was super, super quick. We need to make sure it's accurate. 505, 642, look at the dot products. Yep, everything matches. So this was a speed up of maybe 20 by a factor of 20, 30, right? Cool. Now, computing the similarity is simple. You just divide dot product with the product of user magnitude and client magnitude. This is where NumPy comes in. You don't really need it. I just thought it would be cool because NumPy has functions that apparently don't seem like you need them. Yes?
Could we have used NumPy to calculate the dot product of the
Yes. Okay, great. Oh, wow. I have user number 161,096 has rated a subset of movies that I've rated with the same exact rating. That's great. So he's my best friend now. Okay. But you have a bunch of these similarities. These values might be different for you because you put in your preferences, right? Let's see how this plot looks like. Oh, wow. Oh, no. I'm very basic. I have the same preferences as a lot of people, right? Okay, so in a case like this, I have all the similarities calculated. How do you recommend the movies? Do I just take, for all the similar users, let's say top 10 similar users, I take all their top 5 movies, take the union of them, and just present it? Would that be a good way? Yes. Yep, popularity. So that's definitely a thing. So this is where utility functions, as I mentioned, I give you a little bit of teaser, comes into play. You have a bunch of metrics about these movies, and you want to find a ranking system that takes into account those metrics. So I've given you an example. For each movie, you can score it as you take the similarity between you and a particular user, and you take that user's rating for that movie M, and you add that up for every single user that has watched that particular movie. And that would give you a score, right? You could use a weighted average, right? That's what we're doing. Another way we're doing it is we have a similarity threshold. I set it to 95, but honestly, if I probably set it to 0.99, let's see, 0.999, I'll still have a lot of people. But let's set it to 0.99 for now. And let's see how many users I still have in common. Oh, wow, there's 3,272 people that have a similarity score of greater than 0.99 with me. Okay, I'm not special at all. That's great. So the next step would be to get those users, then get the movies that those users have rated, and compute a score for them. And that's what this function does. It drops the ratings that aren't given by similar users, right? So I don't need all the users anymore. I have my posse of 3,000 people. The birthdays are the best. We book out cities. Yeah, and I get all of their ratings, and I calculate local average and local popularity. Can someone guess what that means? So a movie has an average rating, but what is the local average? Yes. Exactly. It's an average of that movie isolated within that group of people with similar ratings, right? So a movie might be highly rated, but if you're in a group that didn't like that movie, that average is going to go down. Same thing with popularity. I'm just having a count. How many people in my posse, in my clique, have seen this movie? That's the hype. That's the popularity score. And then I get those values. Okay? there is a score function here. It has one variable, but it is basically a weighted average of the local movie average rating and the popularity, right? And how you, like what you prefer to give more importance to, you can change by changing the alpha, right? So right now I think my alpha is 0.95. What this means is I'm preferring count over the rating by a large factor. I think the count is 20 times more important to the score than the rating is, right? So I'm looking, personally, I'm looking at it in a sense of, hey, if my friends have watched it, I'll watch it. Sure, why not, right? If you were to reduce it to 0.05, it would be the other way around. You don't care how many of your friends have watched it as long as they've rated it highly, right? But then you might get that one friend that, who just like, oh, that movie's great, and then you go and then you're like, so it's up to you, right? But then once you sort by the score, this is the movies that were recommended to me. Usual Suspects, The Usual Suspects, 7, Silence of the Lambs. I haven't watched it. Oh yeah, one actually important thing. I do drop those 10 movies that I've already rated, right? You don't want a repeat recommendation. That person's already watched it. But yeah, that's it. There's no code afterwards. It's just usually if you're a streaming service provider, you just pipe this, you take the top 5, top 10, package it into a JSON and send it over the internet to this client's laptop, and then it would get parsed and it would show up. That's it.
15,000 recommended movies.
Hmm?
Why are there 15,000 recommended movies?
18,000 actually. Because I took the union of every, see, I had a large posse, right? I had 3,000 people, and over those 3,000 people, they had rated 18,000 unique movies. So I got all of them. But look at these, like this one user has watched this movie. I can drop them, right? Yes. Yes, there will be a full filled and annotated with even more details, including the data processing step that I skipped for you guys. So I'll also have code that shows you how to get those metrics again. And it will be posted sometime soon along with the video. So maybe a week or so. I'm not sure, but I think we'll just make an announcement when it's available. Yeah? That's it, folks. Thank you all for coming to this workshop. Or that's not it, folks. There's things we have to do. Look at this.
Okay, wait, before we fawn over this, thank you, Malhar, for presenting this super awesome code. Okay, pop quiz. Which one of the 3 algorithms did we use? You speak so much. Where are you? I'm going to pick on you. Okay, nice. Pop quiz 2. In the code, Malhar used DF a lot. What does DF stand for? Yes. Amazing. Okay, pop quiz 3. Which other movies were shot at UTSC? Do you guys know? What? Oh shit, really? Yeah. Okay. Christine? Oh, Shape of Water. I fucking love that movie. Okay, so... Sorry, yours? Oh, really? Yeah. Oh, crap. Okay. So, in addition to all of those awesome movies you just mentioned, there's also Shadowhunters. And there's... Yeah. Crazy, right? And there's also Dream Scenario. I haven't heard of this, but...
Because it isn't out yet.
Oh, it isn't out?
Coming soon.
Okay.
He played the professor at UTSC.
I'd attend his classes. I don't know. But yeah, so here's some movies that was surprisingly shot here. But thank you so much for coming and listening. We know that it took a little longer than expected, but we hope you took a lot you took away a lot from it. And as always, there's going to be a lot more events and workshops coming up after this. Those are all of our socials. You can scan the link to our link tree. And yeah, thank you for coming. Class dismissed.
Also, if you have an idea on what you want to learn next or what you want us to workshop on,
Yeah.
reach out to us.
Yeah.
Right? We'll make that happen. You know, I have a lot of free time.
Yeah.
And just thumbs up, thumbs down. Okay, how was this workshop?
Can we
Good.
rate it? Make a system so we can rate it.
Right.
Oh, you want to rate it? Okay. We'll keep that in mind. We'll post that on our story and then you can read it. Yeah, perfect. Christine, feedback form. Okay, but yeah, that's it.
Can I make one? Thank you.
Not